Okay, good morning. Welcome to our physics discussion. That is physics in a smart way. We are in coordinate geometry. We have not gone out of it. In some last videos, we are discussing on straight lines. Now, we shall go over to some important curves. But when somebody talk of curves, you know the number of curves, type of curves, and all those, the list is unlimited. Simply you draw a line that is not straight and that becomes a curve. But we are not going to any randomly drawn curves. We are going to geometric curves. Even if you consider geometric curves, then the list also is endless. But here we shall consider a special group of curves. Those are known as conic sections. Those are known as conic sections. Here section means to cut a thing. If you consider a cone and even if you take a paper cone, that will do a job. If you consider a cone, we try to cut it by a cutting plane, which is flat, which is straight. And if you cut it like this, remove the top portion, then the thing that remains, what do you call it as frustum? I'm not so sure. You remove the top portion and try to look at, you remove the top portion first, try to look at the thing that you have cut, the thing appears as a circle. Okay, you take a cone, solid or hollow doesn't matter. If it is hollow, then thickness must be small. Just make it out of paper or something plastic, loose plastic, all that paper is better. You cut along like this, or you make a section plane to pass. That cutting plane is known as section plane. To pass, the cone is cut into two halves. You remove the top portion. Okay, then try to look at from the top. Look at the thing, the cut portion from the top. So now there you see a very nice circle. If you take a cone and try to cut it or try to pass the cutting plane in an inclined way. Similarly, remove the top portion that is useless and try to incline and try to see the thing that you have cut, the thing that is created by your cutting in a direction that is normal to the cutting plane. Then you see a oval-like figure that is known as an ellipse. Okay, when the cutting plane is parallel to the base, then you see a circle. When the cutting plane is inclined to the base, then there you got an ellipse. Okay, if you take a cone and try to cut it by a cutting plane, which is perpendicular to the base, remove the portion to the right and try to look at from this direction, there you see a curve, typical curve like this, that is known as a parabola. Okay, similarly, if you cut a cone in a typical style, I am not going to the details of it, you can also get a curve that is hyperbola. That is known as hyperbola. But to create a hyperbola, that is a set of two curves, you require two cones. Their tips or vertices must be touching each other, and you have to cut in a suitable way. That is not our concern now. So usually these curves are found out by cutting a cone suitably, circle, ellipse, and next curve is parabola. So very important curve because nature favors it. And the last one is hyperbola, okay, which will be spheric touching. So these four curves we shall be discussing. Okay, they are branded as conic sections. They are special curves which can be found out, which can be created by cutting the cone suitably. Okay, let me clear up the space and go to the curves one by one. Here, one thing I must make it clear. Our main intention is to be just on the equations, on their equations. We shall not go into full-fledged derivations because they will be long to involved, and that is not our purview now. I'll be trying to attach some funny stories so that will help you convince in a slightly better way. But our main objective will be to become acquainted with those equations, with their equations only. If we see a typical equation, how to recognize it, whether it's a circle, it's an ellipse, or a parabola, or hyperbola, that's all. Okay, because we need to move through it quickly. So let me clear up the space. We go to the first curve, that is circle. That is circle. Let us say we go for our coordinate axis because we are using coordinate geometry. Okay, we when you come down to a circle case, a circle can be visualized in two different ways. A circle can be present for you in two different ways. That is circle with the center at the origin, and second can be a circle with the center not at the origin. Okay, obvious. That is obvious. So we shall consider these two type of circles. It is basically our equation. So far as the circle is concerned, developing this equation is very, very easy. And you got some previous acquaintance with the circle. So that makes our job a bit easier. Let us say we have been given a circle whose radius has to be given. Radius is given as r. We consider a point on the circle. The point is having coordinates x and y. So if you show those coordinates, then you know this will be x, that will be y. And if you join the center to the point P, then this hypotenuse-like thing is again the radius. Now you have created a right angle triangle whose base is x, the perpendicular is y, and hypotenuse equal to r. And we have not forgotten the Pythagoras theorem, which says that x square plus y square equal to r square. Bus. That's all. That is the equation of a circle. You may exclaim, oh, that is so easy. My answer will be yes, that is very easy. Equation of a circle is very straightforward. And that is the x square plus y square equal to r square is the equation of the circle whose center is at the origin and the circle is having a radius r. Okay, then we go to the second type of circle, those circles whose center is not at the origin. Those circles, finding their equations also is not so difficult. But first of all, let us clear all those things. So we consider the number 2, that is circle with the center not at the origin, but at the position whose x coordinate is h and y is k. You may be wondering why I have taken this peculiar symbol in place of taking a B or something like that. No, these are the usual symbols used by your math books or mathematics books. So if I take those symbols, then that will be a bit easier for you. Okay, and with radius r. So here center is not the origin, but center's coordinate as given as hk and radius is given, radius is r. So we go for the circle, but first of all, our coordinate axes, they must be drawn. Sorry. Okay. Then we got the circle. The center won't be at the origin, but center will be at a different point, whose coordinate already we have specified. The center is there. Center will be having a coordinate that is h and k. So this must be h. And that must be k, y coordinate of the center. Okay. As usual, if you consider a particular point on the circle, the point will be having its x and y. And if you try to show those x and y, then you know I am using a different color. This will be our x and that will be our y. Okay. So here we have shown the center's coordinate as well as the coordinate of an arbitrary point which is selected on the circle. The point P can be taken anywhere as you like. I am doing a bit of extra construction. I am trying to create a right angle triangle here, whose perpendicular is like this, base is like this, and this is the hypotenuse, which obviously is again the radius. If you try to find the base of the thing, we know the base part will be, obviously, you look at the coordinates of the point and the center will be x minus h. If you try to look at the perpendicular part of the thing, we know the perpendicular is this much, and that is nothing but the difference of y and k. So that will be y minus k. Again, we see a right angle triangle here, and again we employ Pythagoras theorem, base square and perpendicular square equal to hypotenuse square. So that is x minus h whole square, that is the base, plus y minus k square, that is the perpendicular, will be equal to r square. Bas, our job is over and equation of the circle is already there. That is Pythagoras theorem, and that also gives us directly the equation of the circle whose center is not at the origin, but center coordinate is given and radius is given. That is the equation of the circle. And if you take this equation, put h equal to 0 and k equal to 0, if you put h equal to 0 and k equal to 0, we know again the center becomes the origin. So thereby, if you reduce h and k equal to 0, the equation again reduces to the last equation of ours, the equation of circle with center at the origin, and that was nothing but x square plus y square equal to r square. Okay, so these two are equations which are employed for the circles. Circle can be expressed by many different equations like x square plus y square plus 2hx plus something like that. Many different forms are there, but those are employed mostly for mathematics. For physics and for natural sciences, we just require two equations, x square plus y square equal to r square, or x minus, if center is not at origin, x minus h whole square plus y minus k square whole square equal to r square. Okay, that's all about the circles. We shall go to the next curve, and the next curve is ellipse. That is the next curve which resembles a circle, and circle and ellipse are two curves which are closely bound. If you start from a point on the curve, maybe a circle, maybe an ellipse, and you go along the curve, you are bound to return to the same point. Okay, but ellipse is slightly different. The shape of the ellipse is an oval, just like the shape of most of our cricket grounds, the shape of the egg, that is almost an ellipse, okay, a oval shaped curve, that is ellipse. Practically, you can draw an ellipse. Let us say you take your table or drawing table, spread a drawing sheet on it, to take two pins and attach them firmly on the drawing sheet. Okay, the pins should be standing out of the drawing sheet. Take a thread whose length should be longer than if it is 2 times, that is better. If it is 3 times, that is more better. Okay, longer than the distance between the pins, and attach the ends of the thread to the 2 pins. So the thread will be lying idle on the table. Take a pencil, SB pencil will be working better. Put in the pencil here, and push out. When you push out, your thread becomes taut, and then move the pencil here and there. But the posture of the pencil or posture of your hand should be in such a way that that must be pressing against the thread. Okay, you should not exert a great deal of pressure so that the thread will be snapping, but you move the pencil here and there, that traces a curve on the drawing paper, but the pencil must move in such a way that the thread is tight, the thread is taut. So if you move the pencil here and there, you'll be seeing the pencil traces out a curve which is oval shaped or which is an ellipse. Okay, that is the easiest way to draw an ellipse. There are many different ways to draw an ellipse. I think you got my idea. Okay, let me remove this space, remove all those things. So an oval shaped curve is known as an ellipse. Okay, we may have a funny story here. You take a circle, take a wire which is slightly stiff, telephone wires, and all those things. Take a wire which is which should not be very flexible. Your electric wires and all those things, they won't be doing the job. In my childhood, we used to take telephone wires, attach the ends of the wire, and fix it, fix the ends, attach the ends with the help of the thread. So that forms a very nice hoop. And we used to roll the hoop on our village road, regularly beating it with a small stick. And we used to have competition amongst the children who will be making the hoop to roll for a longer distance. So that hoop is mostly circular. So when you try to press the hoop along like this, if you exert pressure, we know the hoop will be getting a shape that is like this, and that is an oval shape. Obviously, the center of the hoop which was here, because these two sides, they move out, you are exerting pressure from here and here. The center will be starting to split. A part of the center will be going to this side, other part of the center will be going to that side. That doesn't happen, but that is my story. So thereby, in place of one center, we got two centers here, and now the form is an ellipse. So in fact, the end conclusion is true. The ellipse will be having two centers, but we do not use the word centers there. We use the word focus, because center is specifically valued for a circle. And because there are two focus, we say the plural is foci. Okay, that is focus number one. This is focus number two. All those will be learning. Focus, eccentricity, all those things will be learning in a regular mathematics course. But that was my story. When you press the thing like this, these two sides, they move out. So center splits and center, it splits into two parts. So there are two different centers. Those are known as focuses or foci. Okay. So that is my story. Okay. That may not be mathematical, but that works sometimes. In case of an ellipse, you have to know that if you take a sort of diameter along this diameter seems to be small with the ellipse that we have drawn, and this diameter seems to be large. Okay, if this is A, from origin to this end, this will be A. If this vertical part is B, then that will be B. Okay, these are not named as diameters. They are known as axes. This axis is known as major axis because that's a bigger one, and this axis is known as minor axis. If you take half of the axis, then that is half of the major axis, or that is known as semi-major axis. So semi-major axis, in our case, we have taken the symbol as A. So if you take this axis, half of that axis, that is known as semi-minor axis. Semi means half. Semi-minor axis, that we have assumed its symbol as B. Okay, we can develop the equation of an ellipse in using a funny story like this. We know the ellipse is having its center at the origin. If, say, for the time being, we take it as a circle, then circle would have the equation that is x square plus y square equal to r square. I am doing a manipulation. I am getting this r to the left hand side. So, or you may divide r square with every term. So that becomes x square by r square plus y square by r square will be equal to r square by r square. That is 1. But we know if we present this equation to an ellipse, that becomes slightly hot. ये बोलेगा, it says, I don't have got any r. We know this part, that is x square. And in place of r square, in place of r, we know a is doing the job. So thereby, we replace here r by a. Along x, what seems to be the radius? Similarly, if you take the other side, y square by r square, you know, along y, b is behaving somewhat as r. So if you replace r by b, then we got the equation of an ellipse. So equation of an ellipse is x square by a square plus y square by b square will be equal to 1. That means x square by semi-major axis square plus y square by semi-minor axis square, that is equal to 1. That is the equation of an ellipse. And in your regular mathematics course, you'll be getting the full-fledged derivations. Our story is half truth, okay? But somehow our basic job is to have an awareness on the equation of an ellipse, what the equation really looks like. If you see the equation elsewhere, then one is to recognize that yes, that is the equation of an ellipse. So for that, I had created some funny stories, which I have presented to you. So x square by a square plus y square by b square equal to 1. That is the equation of an ellipse. Okay. Okay. Today we stop here, and in this video we stop here. We have covered two major curves. One is circle, second is ellipse, and only two are left out. One is parabola, other is hyperbola. Okay, that will be covering in the next video. So thank you for viewing this video. Please give it a like, share, and please subscribe if that is useful. And I am also waiting for your comments if you require something else, if you require some clarifications on some other topics or something else, because as a student, I most often see the issue of the fact that we have created so many institutions like school, colleges, tuitions for the student, but they act at cross purposes. Parents say something, school says something, tuition says something, and student is at a loss. So if you want to have some help from me, I am freely willing to do so. Okay, the thing that ultimately matters is students' benefit, and we all must be contributing towards that instead of harassing the student. So this video did consist of, as you have seen it, we have tried to lighten the issue. We have tried to make our progress quickly by using some funny stories. I will be using those funny stories wherever our things becomes heavy or wherever we require to have a grasp of the situation. Okay, intuitive knowledge and physics is very closely connected with intuition. Physics is not all about mugging up some formulas and vomiting that on the paper. Okay, if somebody wants to master physics and thereby master engineering or any other discipline that is connected to science, then physics has to be mastered. And you cannot master physics by going through the formulas and working out some problems. The topic has to be understood. Theory has to be understood perfectly, or else we'll be always at a disadvantage. Thank you again. Next video, we'll be covering those two remaining curves.